Now let's see the next problem. If y is a mean proportional between x and z, show that xy plus yz is a mean proportional between x square plus y square and y square plus z square. So what is given is y is a mean proportional between x and z they have given. So y is a mean proportional between x and z they have given. So I can write as y is a mean proportional. That means y square is equal to x z. How I'm getting this is, we know that if it is mean proportional, then I'll be writing it as x is to y is equal to y is to z. Y is a mean proportional they have given. So I'll be writing this as x is to y is equal to y is to z. That is x, y, z are in continued proportion. Now product of the extremes is equal to product of the means, we know. So x is a product of the extreme is equal to product of the means. So it is y square is equal to x z. So directly we can write it as y square is equal to x z. It means y is a mean proportional between x and z. Now what they are asking us to prove, that show that xy plus yz is a mean proportional between x square plus y square and y square plus z square. So this also I can write it as to prove xy plus yz is a mean proportional. So I can write xy plus yz the whole square, because this is the mean proportional of x square plus y square into y square plus z square. So this is the thing I have to prove. So let me go to the proof part. So I'm going to consider the left hand side. Consider left hand side. So I'm going to consider the left hand side. xy plus yz the whole square. So this is equal to, I'm going to expand this using the a plus b the whole square formula. I'm going to use the formula I'm going to use is a plus b the whole square is equal to a square plus b square plus 2ab. So I'm going to use this formula to expand xy plus yz the whole square. So I'll be getting a square, that is x square y square plus y square z square plus 2ab 2xy yz. So this I can write it as x square y square plus y square z square plus 2y square xz. So this is equal to, we know that xz is equal to y square. So I'm going to substitute xz as y square. X square y square plus y square z square plus 2y square z. xz is y square, so it becomes y power 4, since y square is equal to xz. So now let me keep this as it is. Now I'm going to consider the right hand side. I'm going to prove that left hand side is equal to right hand side. So consider right hand side. X square plus y square into y square plus z square. So this is equal to, let me multiply, x square into y square, we get x square y square plus x square into z square. I'll be getting it as x square z square plus y square into y square is y power 4 plus y square into z square is y square z square. Now again I'm using the given condition, y square is equal to xz, we know. So I'm going to substitute x square z square as y power this is xy as y square. So already 1 square is it becomes x power 4. So this is equal to x square y square plus xz is y square, one more the whole square I can write, whole square, plus y power 4 plus y square z square again, since given y square is equal to xz. Now this is equal to x square y square. So let me write this term first. Y square z square plus this is y power 4 and this is also y power 4. So 2 times y power 4. Now you can see equation. This is equation 1 and this is equation 2. From 1 and 2, I can say left hand side is equal to right hand side. So we have proved xy plus yz the whole square is equal to x square plus y square and y square plus z square. This implies that xy plus yz is the mean proportional between, this only they are asking us to prove in the problem, is the mean proportional between x square plus y square and y square plus z square, hence proved. Now let's see the next problem. If Q is a mean proportional between P and R, show that PQR into P plus Q plus R the whole cube is equal to PQ plus QR plus RP the whole cube. So what is given in this problem is Q is a mean proportional between P and R they have given. Q is a mean proportional between P and R they have given. So I can write it as Q square is equal to PR. Q is a mean proportional between P and R. So Q square is equal to PR. Now what they're asking us to prove? To prove P plus Q plus R the whole cube is equal to PQ plus QR plus RP the whole cube. So this they are asking us to prove. So let me prove. Now I am going to consider the left hand side and then right hand side. I am going to prove that they both are equal. Consider left hand side. Here PQR into P plus Q plus R the whole cube. So this is equal to, we know that PR is equal to Q square. Now here we have PR. So instead of PR, they can write it as Q square. And already when Q is there, it becomes Q cube. So that means Q, I am writing it as it is. Instead of PR, I am writing it as Q square. P plus Q plus R the whole cube. So this is equal to Q cube P plus Q plus R the whole cube. Since it is given Q is a mean proportional between P and R they have given. Next I am going to consider the right hand side. Right hand side is PQ plus QR plus RP the whole cube. So this is equal to PQ I am going to write as it is plus QR I am writing it as it is plus RP. RP is PR or RP both. It is equal to Q square. So instead of RP I am going to substitute Q square the whole cube. So this is equal to, now I can see Q is common in these three terms. I am going to bring this Q outside the bracket. So it comes with the power 3. So q cube. So here will be the first term is p. The second term q I have taken it outside, so the second term is r. And here one q I have taken it outside, so remaining one more q is there, so it can be there inside the bracket. So this is the whole power 3. So now you can see the both are equal. Q cube, p plus q plus r, q cube, p plus q plus r the whole cube. So both are equal. So from 1 and 2 we can say from 1 and 2 left hand side is equal to right hand side. Therefore PQR into P plus Q plus R the whole cube is equal to PQ plus QR plus RP the whole cube. Hence proved. Now let's see the next problem. If three quantities are in continued proportion, show that the ratio of the first to the third is the duplicate ratio of the first to the second. So what they have given is the three quantities are in continued proportion they have given. They are asking us to prove that the ratio of the first to the third is a duplicate ratio of the first to the second. So first let me write what is given. Solution. What is given is three quantities are in continued proportion. So let me take the three quantities to be x, y, z. Let x, y, z be the three quantities that are in continued proportion. So I'm going to have taken the three quantities to be x, y, z. So these three quantities are in continued proportion is given in the question. These three quantities are in continued proportion means I can write x is to y is equal to y is to z. This implies product of the extreme is equal to product of the means. So I can write this implies y square is equal to xz. So this is given. Now what they are asking us to prove? To prove the ratio of the first and the third. The ratio of the first and the third. So this is the first one. This is the second one. And this is the z is the third one. The ratio of the first to the third. So first to the third means x and z. So the ratio of the first to the third means z. So this is equal to the duplicate ratio of the first to the second. So duplicate ratio means square first to the second. So x square is to y square. So this is the thing they are asking us to prove. X is to z is equal to x square is to y square. They are asking us to prove. So let me do the proof part. Proof. Now what is given, from that I am going to prove x is to z is equal to x square is to y square. X is to, that is x is to y is equal to y is to z we know, and we also know that y square is equal to xz. This implies y square is equal to xz. Now I am going to take the right hand side. Consider the right hand side. I'm going to consider the right hand side and I'm going to show it is equal to the left hand side. Consider right hand side. X square is to y square. So this is equal to x square. I'm writing it as it is, and y square we know it is xz. So I'm going to substitute instead of y square xz. So this is equal to, now in these two terms x is common, I can cancel the x term. So I'll be getting x is to z. So therefore x square is to y square is equal to x is to z. Hence proved. Now let's see the next problem. If y is a mean proportional between x and z, prove that x square minus y square plus z square divided by x to the power minus 2 minus y to the power minus 2 plus z to the power minus 2 is equal to y power 4. So in this problem what is given is y is a mean proportional between x and z they have given. So with this I can write y is a mean proportional between x and z. So given y is the mean proportional between x and z they have given. So I can write y is a mean proportional means, so I can write y square is equal to xz. Y square is equal to xz is given. So we need to prove this part. So let me go to the proof part. I'm going to consider the left hand side and then I'm going to prove it is equal to the right hand side, which is equal to y power 4. Consider left hand side. So this is x square minus y square plus z square divided by x to the power minus 2 minus y raised to minus 2 plus z raised to minus 2. This is equal to, I'm going to simplify this. I can write it as x square. Numerator I'm writing it as it is. Denominator I can write it as 1 by x power 2 x square minus 1 by y square plus 1 by z square. So this is equal to, I'm going to take the LCM for the denominator. Numerator I'm going to keep it as it is. X square minus y square plus z square. Numerator I have kept it as it is. Denominator, the LCM is x square, y square, z square is my LCM. So the first term becomes, where x square is there, y square and z square is not there. So I'll be getting y square, z square minus y square is there. So I'll be getting x square, z square for the second term, and for the third term I'll be getting it as x square, y square. Now this is equal to, I'm going to take the denominator to the numerator. I'll be getting it as x square minus y square plus z square into, if I take the denominator to the numerator, it comes to the reciprocal, it becomes the reciprocal. So x square, y square, z square divided by y square, z square minus x square, z square plus x square, y square. Now this is equal to, now in the denominator I can see x square, z square is there. So I can write x square, z square as y square, because y is a mean proportional between x and z is given. So I can write x square minus y square plus z square into x square, y square, z square, denominator divided by y square, z square minus x z, I can write it as y square, already one square is there, so it becomes y to the power 4 plus x square, y square, since y square is equal to xz is given. So I am changing this xz to y square, and already one square is there, so it becomes x square to the whole, y square the whole square is y power 4 I will be getting. Now this is equal to, denominator I can see y square term is common, I am going to take it outside. So x square minus y square plus z square into x square, y square, z square, the whole thing divided by y square term is common, I am taking it outside. I will be getting first term z square, second term y square I have taken, so remaining y square is there inside the bracket plus x square. Now I can see the numerator and denominator, the common terms. So this term and this term is common, I can cancel, and y square I can cancel. So remaining I'll be getting x square z square. Similarly, x square z square I can write it as y power 4. Since again it is given that y square is a mean proportional between x and z, so y square is equal to xz is given. Y square is xz, so instead of xz I am taking it and writing y square the whole square, so it is y power 4. So we have proved, we have considered the left hand side and we have got the right hand side, hence proved. It is x square minus y square plus z square divided by x to the power minus 2 minus y raised to minus 2 plus z raised to minus 2 is equal to y power 4. We have proved it. Now let's see the next problem. If given 4 quantities A, B, C and D are in proportion, show that A minus C into B square is to B minus D into CD is equal to A square minus B square minus AB is to C square minus D square minus CD. They have asked us to prove. So solution part, what is given is the 4 quantities A, B, C, D are in proportion they have given. So I can write it as four quantities are in proportion. So A is to B is equal to C is to D. Now this can be written as A by B is equal to C by D. I can equate this to some constant K. Now A by B is equal to K. So A by B is equal to the constant K. So this implies that A is equal to dk. Now I am going to take CD is equal to K C by D is equal to K. This implies C is equal to dk. Now I have got A is equal to bk and C is equal to dk. I am going to substitute A value and C value in the in A minus C, B square is to B minus D, CD I am going to substitute. Similarly, I am going to substitute in the right hand side term also. And I am going to show that left hand side and right hand side both are equal. Now I am going to consider the left hand side first. Consider left hand side. That is, left hand side is A minus C into B square is 2. That means divided by B minus D into CD. I have considered the left hand side. Now in this terms, I am going to substitute A and C value. A value is BK minus C value is DK into B square divided by B minus D into C value is dk, so already one d is there, so it becomes d square k. So this is equal to, I can see in the numerator k term is common, I am going to bring it outside, k b minus d b square by b minus d d square k. Now I am going to cancel the common terms. K is common, I am going to cancel k term. B minus D and B minus D is common, I have cancelled. So remaining I am getting B square by D square. So keep this as it is. Now next I am going to consider the right hand side term. Consider right hand side. The right hand side term is A square minus B square minus AB is 2. That means divided by C square minus D square minus CD. So this is equal to, now A I am going to substitute, A is BK, B square, K square minus B square as it is I am writing, minus A is BK, again one more B is there, so it becomes B square K divided by In the denominator, I am getting c square is d square k square minus d square as it is I am going to write minus c is dk, so d square k. Now this is equal to, now in this term d square term is common in the numerator and d square term is common in the denominator. I am going to take it outside. B square I am going to take it outside, so inside the bracket I will be getting k square minus 1 minus k divided by, in the denominator I am going to take the d square term outside. D square if I take outside I will be getting k square. In this side d square I have taken outside, so it goes minus 1 minus k. Now I am going to cancel the common term. So common term in the numerator and denominator is k square minus 1 minus k is there in the numerator and denominator. I can cancel. So remaining I will be getting, which is equal to b square by d square. So this is your first equation and this is the second equation from 1 and 2. From 1 and 2, left hand side is equal to right hand side. Now you can see in the first equation, when we consider left hand side we got b square by d square. When we consider the right hand side, again we are getting b square by d square. So left hand side is equal to right hand side. Therefore we have proved a minus c into b square is to b minus d cd is equal to a square minus b square minus ab is to c square minus d square minus cd, hence proved.